Hey everyone, Matthew Lockwood here. In this video, I'm going to be going over the process of using Simco Edit 8 to simulate your G-code programs at home. So Simco Edit 8, this is a software that is available to all Fanshawe students through the Fanshawe My Apps. It's really convenient because, of course, it allows you to simulate any G-code program you have written at home. Make oh my goodness, troubleshoot and edit any of your program prior to you coming to the lab, which is really nice because of course it's going to save you time and make it more efficient when you are actually in the lab. So right now, as you can see, I have Simco Edit already on my recent bar within my Fanshawe apps. What you're going to need to do is you're going to need to go in, you're going to need to make sure you find this, and then you're going to want launch the Simco Edit 8 software. It is very important to realize that you do want to have your VPN running as well, especially if you are off campus. So what I'm going to do is I'm just going to turn on, or excuse me, launch the Simco Edit 8 software. And while this is working, I'm going to show you what my file is that we are going to be editing. So this is the part here that we're going to edit. It's a really easy part. We're 4 inches by 2 inches and we're 398 thou thick. As you can see, we have 4 holes, so we're going to drill these 4 hole locations. It's also important to realize that we have a countersink at the very top of these. The countersink diameter is 330 thou at 90 degrees. And then our drill depth, our drill diameter is 266 thou. And it's really important to realize that these 2 holes here are drawn as through holes. These 2 holes here are drawn as blind holes. So not only do we have those 4 hole locations, we also have these 2 slots over here that we're going to machine. They are 0.187, or the radius of the slot is 187 thou, which realistically means the width of my slot is going to be 3/8 of an inch. So again, this is just kind of the basic part that we're going to be going through right now in order to go through the Cimco 8 editing software. Again, that is available to you on the Fanshawe My app. So again, please make sure you get this going. It's realistically, it's totally up to you whether you use this or not. It is really nice. It's super efficient. Like I said, it's going to save you a lot of time. A lot of students do want to edit their programs outside of the classroom, and this will really easily allow you to do that, okay? So when you open up Simco 8, you're just going to kind of go to this screen here, and of course we have a whole bunch of things going on top. We need to make sure that we load our program in. So what I have is I actually just have my program saved on a standard notepad file. So here it is. Here you can see I have my 3 tools. I have my 90-degree start drill, I have my 0.266 drill, and then I have my 3/8 end mill. So all 3 of my tool paths, everything's written out in notes, and it's also important to realize this is done in Fagor language. So what I'm going to do is, within Simco Edit, in order to allow me to edit the software, the first thing I want to do is I'm just going to go to my editor, and I'm going to go to New. And when I click New, this is what my screen will now change to. This is the area that my program would go to. And realistically, if you wanted to, you could get to typing and say, T01, M06, and go through and type your program this way. That's fine. Like I've already shown you, I already have a program written in Notepad. I personally would write your program in Notepad first, because that way you can save it and you can use this on our simulators in the lab as well as Simco Edit. So what I'm going to do is I'm just going to highlight all of my text. I'm going to copy it, and I'm just going to come to Simco Edit, and I'm going to paste it in here. And as you can see, I have all of my information here. Here's my entire program, and I've just dropped it into the editor portion of my program. So right off the get-go, when you are looking at your program, Simco Edit is kind of nice because it kind of looks at it and it determines what type of motion you are making prior to you even backplotting or you simulating your file. So it's kind of cool. Anything in black, you're really not moving. So as you can see, I'm loading my tool, performing a tool change, I'm reading my work offset, and then we start getting into commands where we are actually moving. So in this, you're going to notice that anything in red is technically us rapiding. So if you look at this line here, you can see that I'm doing a can drilling cycle. And for those of you, maybe we haven't gotten to can drilling cycles at this point in your class or not, let's just kind of bear with me and realize that this is my program. it's all going to look the same, even if we're using simple motion commands. Maybe this command line's a little bit different. But the reason that even my can drilling cycles are red is because there is rapid motions between each one of these locations within that drill cycle, okay? So again, your tool's not moving in your G80, that's why it would be black. Anything that is using simple motion commands where you've moved into like either a linear or an arcing command, those will be in green. Okay, so again, Cimco Edit just kind of breaks down your code into different color quadrants to kind of allow you to easily visualize what your tool is doing. And I mean, again, this is one of those things where technically we are not rapiding in these lines here because we're going to be drilling holes, but because we are rapiding from one location to the other, Cimco Edit will show these as red. The next thing that we're going to do is we're going to go to my backplot area. And what I'm going to do is I'm just going to click some of my programs at the very top, but I'm going to come up to here at the very, very, very top, and I'm going to select this backplot tab. So the first thing that I want to do is I need to set up my backplot for the machine style that I'm using. As you can see, I've already kind of messed around with this a little bit, so I already have this as Fagor milling. By default, yours will automatically be in Fanuc milling. So what I'm going to do is I'm going to go to my backplot setup, and I'm just going to come over here, and where it says control type, and like I said, mine already says Fagor milling. Yours is probably going to say Fanuc milling. This is what you are going to have highlighted, which makes the most sense because it's the most common in industry. What you need to do is if you start looking down, you're not going to be able to see it. You actually need to scroll up, and the one directly above Fanuc milling is Fagor milling. This is really important that you highlight this because, of course, if we are using can drilling cycles, we're going to have different variables. So obviously with Fagor, we have a Z is where we're starting to drill and I becomes our depth. Whereas we know with Fanuc, R is where we're going to be starting from and Z is our final depth. The other reason it's important to do this in Fagor milling is because, of course, we don't have an H value for our tool height offset. We have a D value. Okay, so once you have Fagor, what we're going to do is we're going to select OK, and you should see that this here is now showing that we are going to be backplotting within Fagor milling. The next thing that we're going to do is we're going to choose solid animation. And what solid animation does is basically it's going to give us a solid brick of material and say, okay, here's your workpiece, this is what we're milling. And what Cimco Edit does is it actually reads your code, and you're going to see that there was a little bit of time that it took between me clicking solid animation and for it generating this block of material. And the reason for that is because it actually goes through your file, it looks at your code and goes, okay, determine or based off of the X and Y values that we have in our program, this is the size of material that we will need in order to machine this for all of our tools to be able to move in and around to machine whatever our workpiece is. So right off the get-go, I can kind of tell that I have issues because this piece of material here is much different in size to this drawing that I currently have. Now, I have two options here. If I want to, I can go back, whoops, as I open and close every file. There we go, every screen. I've got all the wrong screens coming up. But right now I've got kind of two options that I can do. I have option number one, I can set up my tools, and option number two is I can set up my solid material. So again, it's very similar to the process that you would be following in the B1016 CNC lab. So what I'm going to do is, in this case, I'm going to set up my tools first, and then I'm going to set up my material. So in order to set up my tools, and that would be to set that I have a 90-degree start drill, that I have a 266 thou drill, and that I have a 3/8 end mill, I'm going to go to this tool setup area. And when I click on my tool setup link, you're going to actually look and see, and again, Cimco Edit's pretty smart. It comes in and it goes, oh, okay, perfect. We have a tool 8 registered, a tool 9, and a tool 10. And it's determined this because it's literally just read our program and gone, all right, sweet, we've got 3 programs, or excuse me, 3 tools that we've programmed. These are what they're going to be. Now, I already have messed around with this, and so mine is showing that my tools are perfect. Yours will not be like this, and I kind of wish it didn't do this for this demonstration. I wish it showed these were wrong, but what we need to do is we need to set this information. So right off the get-go, if I come over here, I can see, okay, my tool number 8 is my 90-degree spot drill. So yours may say bull mill or end mill, anything like that. What you need to do is you're going to come to your type, you're going to drop down this menu, and you're going to look to see what your tool actually is. So again, mine is a spot drill, so I'm going to make sure that I choose spot drill. And the next thing we have is we can input what the diameter of my tool is. So again, my diameter, I'm just going to choose it as a 1/2 inch spot drill, just like we've been using with all of our other spot drills within our course. So I'm going to to set my diameter, and the next thing that I'm going to do, or one final thing that I can do, is I can also set the angle of this spot drill as well. In order to do that, if I select this icon right here, I can enter in my tool setup menu. Here it is, and what I can do is I can come in and say, hey, the angle of this tool, it's not going to be 0 degrees or with a flat bottom, it's actually going to be 90 degrees. And when I insert this at 90 degrees, you're actually going to see that this image here has changed to represent that my tool has a 90-degree drill angle at the very bottom of it. So now that I have this tool correct, I'm going to click OK. And I'm going to move on to my next tool. So again, my tools, they're already set up nicely. Yours will not be, but I'm just going to go through the process of what I initially did in order to set all of my tools up. So again, tool number 9, it is a type drill, so I'm going to come and choose drill. I can change my diameter to 0.266, just like it already was. It's also I believe a 6.5 millimeter drill if I wanted to input it like that as well. And then the next thing I can do is I can go to tool setup, and if I wanted to, I could set, what my diameter is. Of course, it's 266 thou. I can set what my flute length is, any of my taper angles, things like that. And I'm actually just going to play around with this really quick and see if 118 degrees, realistically 118 degrees would be what your drill tip angle is. I just wanted to see if that's what this was adjusting. I'm going to delete that again and put that back to 0. And see what it does. So I think it's not your drill tip angle, tapered angle. I'm not 100% sure what that one is changing. I'm just going to leave that at 0 for right now. And then lastly, my 3/8 end mill. Again, end mill flat, it is really important. We don't want a ball nose end mill. A ball nose end mill is one that is fully round on the end. We don't want a bull nose end mill. A bull nose end mill still has a flat, as well as corner radiuses. We want a flat end mill. And we also want to make sure that we have our diameter of 3/8, and that's just the diameter that I've programmed this end mill. Of course, the tools you're programming will be different. And I'm going to click OK. So this is perfect. Now Cimco Edit knows, cool, we have 3 tools, Tool 8, Tool 9, and Tool 10. This is the tooling information, and we've matched our tooling information to our actual program. If you come into your tool setup and it shows like Tool 8, 9, and no 10, what you need to do is you need to look in your actual toolpath and make sure that you have a T10 and a D10 here, because of course that's the information it's reading. So if you have 2 T9s and you forgot to, maybe you copied and pasted this toolpath, you forgot to change your T and D values, it will not register that you have a third tool. It will just assume that you're only using those 2 tools. So again, if all of these don't show up, you're going to need to look through your program and make sure that your tool numbers and your D values are in your program and they are correct, okay? So I'm going to click OK. The next thing that we need to do is we need to change my solid material to match what my workpiece is going to be. So again, I'm just going to open up my drawing because I can't fully remember where my datum is and I can't remember the sizes off by heart. So my datum is in the top left-hand corner. That means that I'm going to have a max in my X. I have no min in X. I'm going to have no max in my Y. I'll have a min in my Y, and my thickness is 398 thou. So I'm sure just by me even saying our max and our min, you're going to realize like, oh, okay, this is very similar to the simulators that we use in the B1016 CNC lab, and it is as far as how we set up our material. So what I'm going to do is I'm going to choose solid setup, and again, we have X min and max, Y min and max, Z min and max. So obviously our min represents any material that's in the negative direction from my origin. Anything that's max would be in the positive direction of my X origin. And again, based off of our initial program that we have written, Simco Edit will automatically dictate and say like, we were pretty sure this is the size, like this will work for you, but we're going to go through, we're going to make sure that this is perfect. So again, if I bring my drawing up just this one more time, you can see that I have no min X. All of my material is in the positive direction, and it is 4 inches. So let's bring up Simco Edit again, and we're going to say, okay, my min X is 0, my max X is 4. And then I'm going to come back to my drawing. I'm going to look at my Y. I'm going to say, okay, I have no max Y. All my material's in the negative direction, and it is 2 inches in height or 2 inches wide. So I know that my Y min is going to be -2. So minus 2.0. My Y max is going to be 0. And then we're going to check out my Z, the thickness of my part. It is 398 thou. My Z0 is the top surface of my part, so I have no Z max. All of this material is in my Z min. So again, I'm going to come here and go minus 0.398. My Z max is 0. And after I have that, whoops, I didn't mean to click on that. After I have this all set, I'm going to come in and click OK. And now my part looks much more, or my solid model or solid stock looks much more identical, or is identical to my actual part, right? So here's my part size here, 4 by 2 by 0.398. When I look at this, this should be 4, this should be 2, and my thickness is 398 thou. So now I am ready to start simulating my program. So what I'm going to do is I'm going to click at the very top, and it's kind of cool because of course anywhere I click, you can actually see Cimco Edit will show what our file looks like at that point in time, anywhere that we are on my actual part. But before we do this, if we want to watch my full simulation, really easy. We're going to start at the very top of my program, and down here in the lower right hand corner, you're going to see we have our play bar. If I just press play, you'll see that my Simco edit is moving. Here's my spot drill coming in, and oops, I can already tell that this has gone in the wrong direction. But we see that we've now spot drilled my holes. We're drilling my holes. Let's see. Okay, perfect. This is what it's looking like. Uh-oh, we've got something crazy going on here. And then we're going to be machining my slot. Uh-oh, and we missed this slot as well. So right now, this is what my program is simulating out as. So again, it's nice because it's showing us this, but it doesn't, it's not just going to automatically assume that what we want to do is correct. So it's really, really, really important that we take this file and go, okay, clearly something is wrong. We need to go back through our codes and make sure that what we are doing is correct. So again, if you wanted to, we can come and we can click at the very top of your program. And I believe if we press play again, you'll see that it automatically resets our material as well. So again, we spot drill, and right here you can see that I'm coming off of my part. So clearly I'm moving to the wrong Y location. All my Y values should be negative. So this would be a really good indication that I could come in and go, okay, here I am doing my can drilling cycle. And how would I kind of start working my way through one line at a time? And this is really nice. I can just use my arrow keys to come down. So here I am, I'm moving to this position. My tool is coming 1 inch above. I'm reading my height offset. I drill my very first hole, and then you can see on this command line here, again, all I'm using is the arrow keys on my keyboard right now to physically go through every command line one line at a time. You can see that my tool is heading in the wrong direction. Well, that's because right here, this Y value is a positive. And it's not supposed to be a positive, right? All my Y's are supposed to be negative, so it's really easy to edit this. I can come in and I can just put this as a Y negative, and look at this. Simco Edit has already looked at this file. Let's update and go, oh, okay, cool. Well, this is where this location would be if we had a negative value here. So now what I can do is I can continue going through one command line at a time. Again, just by clicking down on my arrow key, and you will see that, all right, great. It's shown me all 4 locations have spot drilled. One thing I will say is Simco Edit does not care for this G53 command. We know that our G53 machine home command, it works fine in our machine, but if I just kind of click and rotate this, you're going to see that it thinks my tool should come back to the top surface of my part. I'm just going to show you really quick. If I were to show this, and again, G53Z0 we know is correct. It will function properly in our machine. But again, if I show this as a G91 G28, you will see that my tool actually moves up off the top surface of my workpiece and would move to that home location, right? So again, G91 G28, it's going to show that my tool goes up. Does it matter if we do a G91 G28 Z0 or a G53 Z0? Absolutely not. Personally, I would stick with the G53 Z0s. I think they're a lot safer command, especially because we don't need that incremental motion in there. But again, if you're wondering why my tool is finishing on the face of my workpiece, for some reason Simco Edit does not like that G53 command, okay? But anyways, where we are right now, we have now done a really nice job. We've gone through and we've spot drilled all of our holes. So again, if I want to come to the very top of my program, I can come in and press play. And if I want, I can use my scroll button to zoom out or to zoom in. Everything looks really great. I'm just going to come down here on the stop button so I can watch this. So here I am. I'm going to drill this hole. I drill 1. I drill 2. These are my through holes. And then I drill this third hole here. And you're going to see that it's like doing something crazy. It's literally just double drilled this hole twice, which is really strange. So what we're going to do is we're going to actually come back up to my second toolpath, my can drilling cycle, and we're going to kind of go through that manually again. So I'm just going to be editing through this with my arrow keys. So we come 1 inch above, We begin our drilling cycle, beautiful. We move to my second location, and if we wanted to rotate this, we can see that it goes all the way through, so that's good. We come down here, and we drill our third hole, and then it kind of gives us some issues, and it never moves over to this location. You're going to see that I'm at my G80 command. Why did it not read this command line here? So something is wrong with this command line, and this is something that I do not really like on Simco Edit, is because it'll just kind of like what you saw in that animation. It will stutter. It won't give you an alarm, which kind of annoys me. I feel there should be a big red bar come across being like, yo, there's something wrong with this command line. So when I look at this command line, this is the one that's giving me issues, even though technically X 1.625 is correct, the correct location, it's not moving over and drilling this hole. That is because, and again, I'm just going to look over here, and it's really hard to see, this N0, this is not a 0, this is an N-O, the letter O. So I need to change this. I'm going to put this as a 0, and right beside it, I'll put the letter O. And as you can see, there is a tiny, tiny, tiny difference between what is a 0 and what is the letter O. Letter O's are perfectly circle. Number zeros, they're oblonged, okay? So that is why that was giving me that like little mini like seizure moment there on my part where the drill was just going down and up. It's because it was reading this and it was giving me an error on that command line. So now when I drill this and I move through manually, you can see it's now drilling that whole location, okay? So again, if I want to, and this line here, the reason it's coming back down to the top of my surface is because that G53 command line, that's not a make or break. So again, if I press start at the very top of my program, my tool comes in, it changes to my spot drill. Beautiful. We spot 1, 2, 3, 4, all those locations. Wonderful. We know this tool is correct. Now we're drilling with my 266 drill all the way through. We're going to come here. We're going to drill this one once. Wonderful. And now it's drilling that hole as well, which makes me happy. My next command line is we're coming in. We're going to mill these slots. And at the very end, of course, we're going to see that we're having issues. It did not drill this slot or did not mill this slot over here on this side, right? So if I look at my part, I should have the 4 holes. Yay, I've got that. I've got this slot machined. I'm missing this slot here. So what I need to do is I need to, again, look at my code and figure out why that is like that. So the easiest thing I can do is once again come through and individually go through each command line and see where my problem is. So I move into position, I come a 1/4 inch above the top surface of my workpiece, I turn my coolant on, I'm feeding down, and again, because this is a green, we know we're using a simple motion, so I'm feeding into my part Z minus 0.078, and now my next command line is moving in my Y axis to machine that slot. I rapid my tool up, I move to my next location, and I'm feeding what should be down, and I move across to my other location. So it's moving across, it's not going into my part. So again, really easy. If I look at this, I have no Z negative value here. I've stayed up above. I'm supposed to be 78 thou deep. I forgot to put my negative symbol in. So all I have to do is put my negative value in here. Simco Edit will read those command lines. It will automatically adjust. And now you can see I've machined that slot. Boom, there it is, M30. I've now just verified that this part is pretty much correct, right? I've gotten rid of any of those issues. And again, if I press play, I can zoom right in on my part if I want to. And again, we spot drill 1, 2, 3, 4, and you're going to see I've really cranked up how fast. This is obviously how fast your simulation is going to run. I've got mine moving very fast just because I don't want to wait around for forever. But again, here we are, we've drilled our 4 holes. That movement there was at G53. We come in with our 3/8 end mill, we machine our slot, and now we machine our other slot. Don't worry about, like I said, it coming back down towards the surface of my part. That's just because it does not like that G53 command. Don't worry about that. But anyways, now when we look at this, we go, okay, perfect. We have essentially a wonderful part here. This looks really good. We know that we have a program that's going to function a lot nicer and have way less issues with it when we come to the B1016 lab. We've already gone through it. We've double checked to make sure that everything looks okay. We can now, again, take this file and I can do a Control-A to highlight everything. I can copy it. I can pull my original file up, and I'm just going to delete this entire thing. And then I'm going to paste my new version, and as you can see, I have a Z minus 0.078 here. This location here has a 0 instead of a letter O, And what was the other thing I had? I can't even remember. Oh, I know what it was, my Y negative. This was not a Y negative, it was a Y positive before. It has also been changed. So now I can save this if you want to. You can still save this as a BIT. If you want to show this to me or still use our simulators in the B1016 CNC lab, you can. We've done a lot of that initial troubleshooting to make sure that this program would function correctly. Okay, so again, just kind of a really nice, easy software. A quick little run through of a software that again you can easily use on your own to kind of troubleshoot and edit your programs before you come to the lab. Allows you to kind of use your time a little bit more wisely when we are actually together. Okay. So I hope you've enjoyed this video, and I hope that you use Simco Edit and this gives you success with editing your G-code programs. Of course, if you have any questions or any concerns, or you want to reach out to me to ask more questions, please feel free to do so. My email is m_lockwood@fanshawonline.ca. Thank you very much for watching and have a great rest of your day. Bye-bye.